Hi everyone, welcome back to the third video of this data science series. In the first two videos, we saw Python and pandas. So in Python, we saw the basics of how the Python language is, like what are the different variable data types that we have, how do we loop and all that. And in pandas, we saw like how we can analyze the data. And in the third tutorial, like we are going to see how to visualize the data that we have filtered or analyzed. So people who have requested access to this folder already would be able to see this matplotlib file added in the repository. For people who are new, please go ahead and submit the access request through the link provided in the description of the video so that you will get access to this code. And once you have it, you just have to open this matplotlib file using your Google Collaborator. So here when it opens, it is not connected by default, so I am connecting to the server. So Matplotlib is the de facto library used for data visualization in Python. So anybody who has started learning data science would have never crossed the path without Matplotlib. So it's like the most basic library, and there are more libraries available like Seaborn and others which are built on top of Matplotlib. So Matplotlib is the most basic layer, and more sophisticated plotting is available in other packages which rely on Matplotlib. So in today's video, we'll be covering how a graph or the plot is getting constructed using Matplotlib. So Matplotlib is the most easiest way to create plots. So like we have standards for importing, right? So usually pandas is imported as PD, like that Matplotlib is imported as PLT. So I import a NumPy and Matplotlib. So NumPy for generating a sequence so that I can plot it and see how to plot it using Matplotlib. So a quick example. So here what I've done, I'm importing NumPy. So we already did that, actually this is not required. And I'm creating a random values in the range of 0 to 10. I am taking 40 data points. So I will have 40 data points ranging from 0 to 10 in my X array. Then for Y, I just square it. So basically I'm going to draw a line Y is equal to X square. Okay, so before that I print. So here you can see this is my X value. So I have values starting from 0 to 10, and there are 40 data points, and for each of them, like the square of that value is given in the Y column. Now let's see how to plot. So inbuilt function plot is available. So by default it plots a line plot. So you can see, right, this is my x-axis, this is my y-axis, and I have a plot of y is equal to x squared. So now you can see that everything is empty, right? You don't have any notation for the x-axis or y-axis. You don't have a title, you don't have annotation legend, nothing is there. It's just a simple plot. You just can create a plot using inbuilt function plot to create a very basic quick fire plot. Now let's see how to customize the axes. So for that we have keywords like x label, y label, and title. So now I am saying like my x-axis is this, y-axis is this, and the title. And in addition to that, in the plot I give one variable saying what should be the color of my plot. So here B represents blue, and other values are like R for red, G for green, and so on. Now let's see how this output comes. So you see, right? So whatever I put in this spot will come in the x-axis, and whatever I put for the y-axis will be here, and the title comes here, and the plot is plotted in blue because I gave the keyword as B. Now if I change it to R, you can see that the plot color changed to R. So like this you can do any customization. Similarly for x-axis, say you want to give just a number range, and for y-axis if you want to give squared output, because that's what we are doing, right? So now if I run this, so you can see the plot in red. You see the x-axis changed to the text I give here, and y-axis getting changed. So like this you can customize your x, y and the title. Now, say for example, so far we have been seeing creating one chart, right? But in real time, in lot of applications, you need to create charts side by side, or four charts or five charts, and compare them. So when you want to create multiple plots in the same graph, Matplot provides a feature called subplots, and by using subplots you can add different axes so that you can build multiple graphs within just multiple plots within one graph. And for that we need to define axis. So axis is defined with four variables, where your first two variables represents the point where it starts. So it gives the x and y variable where it starts, then it next column, next parameter says what should be the width, and the fourth parameter says what should be the height. So let's see it with an example. Now I'm saying I need to add axis from 0 to 0, then height is 1, width is 1, meaning like I want to plot it for the entire space. Okay, so this is how my plot looks like. It starts from 0 to 0, then I have a width and height of 1, meaning like these are percentages, meaning like I need to have it for full length. To understand more, here I'm doing two plots, or I'll run this then explain how this works. So here in the example, if you see, the first one starts from 0 and 0.6, right? So this is my x-axis and this is my y-axis. So in the x-axis I am saying 0 and y-axis 0.6. So this is 0, and if I take like this is my 0 and this is my 1, my 0.6 will lie somewhere around this point, right? So this becomes my 0 and 0.6. So from that point I am saying my width should be 1. So it takes the entire space. This is the plot available. So this is the overall size, right? So across this I'm saying my width should be 1, meaning like 100%. So from it starts from 0, 0.6, it goes till the end. Then my height should be 0.4. So it started at 0.6, right? So 0.4 will be like till 1. So this becomes my height. So my first plot is this. My second axis I am saying it should start from 0 comma 0. 0 is comma 0 is this, right? X is 0, y is also 0. So it starts from this point. Then I am saying the width should go till 0.8. So from here till here is 1. So 0.8 lies at this point, and height I am again saying it is 0.4. So it goes up till here. So this was 0.6, right? So this is 0.4. So this is how you define the axis. Similarly, you can split for any number of numbers. Like if I want to have 4 graphs here, I can plot like this. Until this point I can create one subplot, and for this I can create one subplot, for this I can create one subplot. Like this I can do it however I want. Now let's move on to the next one. So here I'm trying to build a chart inside another chart. So when I run this, so this is the output that you get. So the same logic again. So here it starts from 0 to 0, right? So my axis 1 starts from 0 to 0. Then it goes till 1, which is this point. Then height is also 1, so this point. So this is my axis 1. My axis 2 starts from 0.5 and 0.5 for both x and y. So this is my 0.5 for x, right? And this is my 0.5 for y. So these are my 0.5 points, right? So my 0.5 comma 0.5 starts here, and from there it goes till 0.4 for width, which is this, and for height it goes for 0.4. So my axis 2 is defined by this plot. So like this you can build a plot within a plot by defining the axis ranges. Let's see another example where we can customize multiple plots. So this is just to show you that I can draw my plot anywhere and divide the plotting area into the different subplots. So here I've drawn 5 different plots, you can see, right? So there are 2 unique charts. There is one which is diagonally long, one which is horizontally long, and another rectangle plot. So like this you can customize how many ever charts that you want in a single graph. So in the other example, so you saw 5 plots, right? Here we are just trying to plot a data into each of those axes. So now AX1 is my axis, right? So in that I am drawing a sin x. In my axis 2 I am drawing a cos x. In 3 I am drawing a tan x. In 4 I am adding x cube and x to the power of 4. Now let's see how the output comes. So here, right, you see a sin x, you see a cos x, then you see a tan x, then you have the x cube and x to the power 4. So far we saw how you can plot a simple plot. Then we saw how to customize the x and y strings. Then we saw how to add title. Then we saw how to split your plotting area into different subplots and add data to it. Next, we will move on to see what are the other formatting options that are available. So the first one, we will see how you can change the axis font and color. So here you can see for X plot, I am saying like it should be sin X wave, and I am giving my the plotting variable as G, meaning green color. So my plot is now in green color, and for X label I am saying the value is X, the font size is 15 and color is red. So you can see, right, X is plotted here and you see the font size is 15 and color is red. Similarly for Y label I have given like it is a sin X function, then I am saying like font size should be 20, color should be B represents blue. So here in the Y column you see a blue text saying sin X. Right now, so far we have been seeing like how you need to format your x-axis, y-axis, and with respect to the graph we saw only the color changes, right? There are much more formatting that you can do, so we'll see that in the next section. So here I'm saying my plot should be a sin x curve, and I'm saying my color should be G, which is green, and I have an additional dot, meaning like instead of a line plot I want my line to be denoted by multiple dots. So when I run this command you can see like the graph separated by dots instead of lines. Say instead of dot you want to separate your line space with hyphen. Instead of dot you can give like G hyphen. So now your graph is represented by a hyphen, and there are other possible values for it. So here you can see, so line width I'm customizing for these 4 like 0.25, 0.512, meaning like the strength of the line. Then for step I'm saying like it should be a hyphen, dot, colon, then different markers. So if you see the output you will get an idea of what I'm trying to. So these are the different line types that you can create using your Matplotlib. So this represented that line width. We gave 0.25, 1 and 2, right? So you can see how based on line width the graph can be separated in the first 4. And in the second 4, like you see how the notation differs. You have a line, you have a dot, then you have a dash, then together you have. So these are the different possible combinations that can use for plotting your lines. So now let's see how to plot two different plots in the same axis. So earlier we saw, like, we had one graph which we divided into multiple subplots, and each subplot we plotted a data point. Right now what we are going to do is, like, within the same plot I'm going to draw two different lines. So here I have plotted both a sine wave and a cos wave, and to differentiate them, for a sine wave I have given a dot notation, and for the cos wave I have given a complete notation. So you can see, right? So with the same axis I am plotting two different functions, where one is like x and sine x, the other one is like cos x. For sine I have given, like, it should be in green color with the dotted line, so you get that. So next, adding legend. So again, you have an inbuilt function saying legend. So I give like x1 of legend is location equal to 1, meaning like it will get into the upper right corner. So if you want to display it in the other places, you can change it. Say like I have given it in the comment section. So if you want it in the lower left corner, say your location should be 3. Now I rerun, like, location equal to 3, and I run it. So now you get your legend in the lower left corner. Like that you can customize your legend as well wherever you want to display it. Next, another important function is customizing your range. So far we did not give any range at all, right? Based on the data points that was given for plotting, Matplotlib shows the range as 0 to 10 for x and -1 to 1 for y-axis. Now say you do not want to have it between this range and you want to customize it for a particular range, you can use the range limit. So that is done using this set x lim and set y lim function. So here I am specifically saying my limit should be 0 to 10 and my y limit should be -2 to 2. So let's see the graph. So this is how I get it. Now you can see the change, right? When it was plotted between 1 and 1, you saw a graph which was kind of elongated. So here when I set my limit to -2 and 2, now this looks like shortened, right? So limit is very important when you compare between two variables. So by changing the limit, my trend will remain the same, but the graph for the human eyes may look different. Now when I say my limit is -3 to 3, again it got shortened, right? So like that you can play around with the range as well. Now say you want to add some text to your plots. You can do that using your text method. So here I am saying the same graph that we plotted before, but the only additional thing is, like, I have a text method to add this particular text with font size as 15 and color as red. So that got printed in the text. Say you want to have control over your graph, or do watermark your image, or add some branding to your graph before taking a screenshot or saving the image. You can use this x1 access.text method to add text to your plots. So next we will see what are the different types of plots available in Matplotlib. So far we have been seeing all customization, how to do, right? So now we will see what are the different plots that you can create using Matplotlib. So the first basic one is your line plot, which we have been saying so far. So you have two variables, one on the x and one on the y. So you plot it. It's a kind of a continuous variable, right? So when you have a continuous variable, we most commonly use line plot. So for that we use the method as plot, right? This is what we used in the simple example also. Next we will see how to implement a bar chart. So in a bar chart, most of you would be aware, right? So either horizontally or vertically they are stacked, and now 0 means like what is the value, 1 means what is the value, 2 what value it has. So here you can see I have given two random data, and the method for plotting bar chart is bar, and you can see what are the different parameters that you can give. So you see, right, you can set what is the value that you want to plot. You can set what should be the height, width, whether you want to do it in the bottom, you want to align it to center. So these are the different parameters that you can use for customizing your bar chart. So the next one is horizontal bar chart. So here the bars are vertically stacked, right? So when you plot a horizontal bar, you will get a horizontal bars. So the method for doing it is bar hedge. So when you use bar hedge, you are going to get horizontal bars. So next we also have stacked bar chart where you have three variables. So you have one on one variable compared, and within a variable you have certain categories within themselves. So that can be differentiated using stacked bar chart. So like you see, this is one variable in x-axis, then you have one variable in y-axis, and within that plot you have two different categories. One is represented in blue color and one in red color. So it's not necessarily like it should be binomial. There can be n number of categories, and each category will come as a different colored stack. And to do that, I plot two bar charts, so one with color blue and one with color red. So pie charts are circular representation. So you have they are most commonly used when you want to know relative weights of different features. Say you have 0 to 100 range, out of which how much percentage is contributed by each of your variable can be easily understood through a pie chart, because the weight of the wedges in your pie chart will be proportional to the weight of the quantity. So here by just looking at this pie chart, you can see, like, categories is the highest, sorry, computer is the highest category, and then followed by electronics, chemical and mechanical. Though there is no number representation here, you can very well understand what is the weightage of each of the category just looking at this pie chart. Next is your box plot. Box plot is something that we do not encounter in our day-to-day life, right? Or at least not as frequently as your bar chart or pie chart, which you see everywhere. Box plot is a statistical plot used for seeing the distribution range of your data. Say you have a data with 100 data points. This orange line represents your mean value or your median value. So where your center applies in your data is represented by this orange line, and this represents your Q1 value or quartile 1, meaning like from this point 25% of the data that you have will lie between this median point and Q1. Similarly, you have a quartile 3 here. So there will be four quartiles, 25% data, 25, 25, 25. Your 50 or your center will be this orange line, and this will be your quartile 1, this will be your quartile 3. And this flicker is nothing but your 1.5 times the distance between your median and Q1 is this flicker point, and any value beyond this, now you have this data point, right? This is your outlier. Similarly, you have a bottom flicker which is like 1.5 times of the difference between Q3 and Q1, which is this point, and any data beyond this line becomes your outlier. So you have two outlier points here, and we will examine it for additional analysis. And the primary objective or most commonly used application of your box plot is to identify outliers like these. Next, we will see area chart, which is similar to your line graph, but in the output you will see the area under the curve getting colored into different areas. So here, say you had four data points like sleeping, eating, working, how much time is spent on each of that on 5 different days. Then I do plot a stack plot. Stack plot method is used for plotting your area chart. So here you can see, like, how the value varies. Then the final chart that we'll be seeing is a scatter plot, which is used for finding relation between two variables. Say you have two variables and you want to know like how they are related to each other, you do a scatter plot, and we use method scatter for plotting a scatter plot. So this is how a scatter plot looks like. So in today's video we saw like how you do a simple plot, then we saw how you customize the axes, how do you plot multiple subplots within the same graph, then we saw how you customize your x-axis, y-axis, your title, your legend, your plotting lines, the width, the color, the how the representation of, whether it's a straight line or a dotted line and stuffs like that. Then we also saw different kinds of plotting that is provided by Matplotlib. So this list is not comprehensive. Matplotlib also provides the user with the ability to build more complex charts, but at a beginner level, this course is sufficient for you to understand all the basic components that build up a chart. So more advanced charts we will cover it up in the upcoming sessions as we learn more about data science and machine learning. Thanks for watching this video. If you find the information useful, please share it with your friends or colleagues who might also find this information useful. Thank you.